Okay, so you should have in front of you a copy of the Delicious Dogs worksheet, and you're going to be filling it out as we go through the video. This is geared to help you understand the formulas and how they're formed and why they are the way they are, because some of them are a little strange. And if I just gave you the formulas, you would not really understand why they work the way they do. So this is corny and it's weird and it's kind of gross, but it will, I think, help you understand the formulas a little bit better. So the idea is that we are going to a fantastic dining establishment called Delicious Dogs, where all they serve are hot dogs and buns and different combinations of the two. So the D stands for dog and the B stands for bun. So we're going to start with looking at the hot dogs. They only serve 10-ounce hot dogs or 18-ounce hot dogs. That's it. So what I want you to do is find the average, the standard deviation, and the variance of just the hot dogs. Now you can do the average in your head. I'm sure 10 plus 18 divided by 2, you're going to get 14. Okay, let me grab my pen. So the average is 14. But if you have to try to figure out the standard deviation and the variance on your own, that wouldn't be quite fun. So get your calculator and you're going to type in 10 and 18 and you're going to label it D. And we're going to have the calculator do the work for us. So we're going to press Menu, Statistics, Stat Calculations, One Variable Statistics. We got one list, and my list was called D. I don't need to change the frequency because we're not making a probability distribution like we did last section. Just leave that alone, hit OK. All right, so there's your mean of 14. The standard deviation is 4. Okay, so we're going to fill that in. The standard deviation is 4. Now, if you want the variance, just literally square the standard deviation. You can see it in the symbol here. Just square it, and you get 16. Okay, now just leave that alone for a minute. We're going to move on to the buns. So they only offer a 1-ounce bun or a 7-ounce bun. Okay, so we're going to find the average, the standard deviation, and the variance for buns. I'm just going to make a new spreadsheet. So we're typing in 1 and 7, and these are the buns. And we're going to do menu, statistics, stat calculations, one variable stats, one list, and I called the list B for bun. Hit OK. So the average for buns is 4, and the standard deviation is 3. So let's fill that in. Okay, so again, the average was 4. The standard deviation was 3, and square that to get the variance of 9. All right, so now what we're going to do is we are going to do a combination of dog and bun. So what are all the different possible values? Well, you could have a 10-ounce hot dog with a 1-ounce bun, and that would give you a total of 11 ounces. You could take a 10-ounce dog and a 7-ounce bun, so for a total of 17. You could take an 18-ounce bun, or an 18-ounce dog with a 1-ounce bun, that'd be 19. And you could take an 18-ounce dog with a 7-ounce bun, and that would be 25. So those are all the possible values. So go to your calculator. Okay, so we're going to do 11, 17, 19, and 25. And I'm going to say, I'm not going to type in D plus B just because the calculator might wig out. So I'm just going to use X just because. All right, so then I'm going to do menu, statistics, stat calculations, one variable stats, and I called it X. Hit OK. All right, the average is 18. The standard deviation is 5. Okay, so average was 18, standard deviation was 5, And if I square 5 to get the variance, I get 25. Okay, so we're going to just stop there for a second, not stop the video, but just pause for a second to look at a formula. So look at when I add two random variables, what do I do with the averages? The average of 14 plus the average of 4, I get my average of 18. So I can just add the averages up. So let's write that formula out. If I want to find the mean of D plus B, I can just take the mean of D, which was 14, and add the mean of B, which was 4. I add those up, I get the mean of D plus B. Okay, now let's look at the standard deviations. Can I add those up? Can I do 4 plus 3 and get 5? No, you cannot. So you might want to make a little note of that. We do not add standard deviations. Okay, we cannot add the standard deviations, but we can add the variances. 16 plus 9 does equal 25. That we can do. So to get the variance of adding two random variables, we can take the variance of D and add the variance of B. We can add the two variances up. Well, now, how do you get the standard deviation? Well, all you have to do is take the variance and do the square root of it, and you get the standard deviation. So if you want the standard deviation of D plus B, all you have to do is take the square root of the variance of D plus B. Okay? So we have a formula for mean and we have a formula for variance, and all you have to do to get the standard deviation is just take the square root. Okay? Now, keep in mind, when you take the square root, so we're going to take the square root of this stuff. Okay, when you take the square root of those, you are not mathematically allowed to split those up and take the square root of each. That does not equal the standard deviation of D plus the standard deviation of B. Mathematically, that's not true. Again, look, 5 is not equal to 4 plus 3. Those are the standard deviations. We do not add them up. Okay? So just kind of keep that in mind. All right, the next thing we're going to do is we're going to take a chomp, which is the C. And it's like taking a bite out. We're going to take a 1 ounce chomp, or we're going to take a 3 ounce chomp. Okay, so just to save us time, I'm going to give you these values. The average would be 2, the standard deviation is 1, and the variance is 1. Okay, so now moving on, we're going to take a dog and we're going to bite a chomp out of it. So we're taking an ounce, a kind of dog, subtracting off a chomp. So our possible values, we could take a 10 ounce dog and bite out a 1 ounce chomp, and we would have 9 ounces. We could take a 10 ounce dog and bite out a 3 ounce chomp, and then we would have 7 ounces. We could take an 18 ounce dog, bite out a 1 ounce chomp. That would be 17 ounces. And we could take a 17 ounce and bite out 3 ounces, and then we would have 15. Those are our possible values. So again, if we went to the calculator and we typed in 7, 9, 15, and 17, and I'm going to call it Y just because. Go to Menu, Statistics, Stat Calculations, One Variable Stats. My list, I just called it Y. Okay, the average is 12. And the standard, The standard deviation is 4.1231. Okay. So I'm going to write that down. The mean is 12. The standard deviation is 4.1231. Now, if I took that long decimal and I left it in the calculator and I squared it, I would get 17. Okay, now let's look at another rule. Look at what happens to these values when we are subtracting random variables. Compare them to the values we had for D and the values we had for C. So what's happening? If I want to find the average of D minus C, what do? How do I get 12 from 14 and 2? All you got to do is subtract them. 14 minus 2, you get 12. So I'm going to take the mean of D minus the mean of C. I can just subtract the means. Standard deviation, can I subtract the standard deviations? Is 4 minus 1 equal to 4.1231? Nope. You cannot subtract the standard deviations. What about the variances? Is 16 minus 1 17? No. We do not subtract the variances. What do we do? What are we doing with the 16 and the 1? We're actually adding the variances. This is weird. Okay, if I want the variance of D minus C, I actually am adding the two separate variances. I would take the variance of D, which was 16, and I would add the variance of C, which was 1, and I get 17. See, this is weird, okay? If we didn't use the numbers, you would probably be wondering, why do we add when we're really subtracting? It's odd. Okay, but now, again, if I want the standard deviation, all I have to do is take the square root of 17, and I get this value here. So for standard deviation, just square root the variance. Okay, so just maybe make a little note. Anytime you want standard deviation, just square root the variance. Okay. All right, moving on. Now we're gonna do 2D. Now this is gross. If you're looking at the descriptions, the 1 through 9 on your sheet, we're on number 7 right now. So this is a Snoop Double Dog deal, and this is when they take a dog and they mash on another dog of the same size. It has to be the same size. Gross. So you could take a 10-ounce hot dog and mash on another 10-ounce hot dog. So then you'd have a total of 20 ounces. You could take an 18-ounce dog and mash on another 18-ounce dog, and you'd have 36 ounces. Okay, so if we were to use our calculator and get the mean, standard deviation, and variance, you're going to get 28 and 8. And then to get the variance, you just take 8 squared, and you get 64. Okay, so now I want you to look at how does the D column relate to the 2D column. Okay, so what do I do to the 14 to get 28? Well, I double it. Makes sense, it's 2D. Okay, so I'm going to write that down. If I want to get the mean of 2D, I just take the mean of D and I double it, multiply it by 2. Okay, let's scroll back up and look at that. Okay, so you just take 14, which is the mean of D, multiply it by 2, and you get the mean of 2D. Okay. But now look at what's happening. Standard deviation. Okay, it looks like I can take 4 and multiply it by 2 and get 8. That seems to work. What about the variance? Do I multiply 16 by 2 and get 64? No. Okay, what are you really multiplying 16 by to get 64? 16 times 4 is 64. And our constant is a 2. So if I want the variance of 2d, oops, sorry. My computer is acting a little weird, very slow. Let me fix that. Okay, so we want the variance of 2d. I'm going to take the variance of d, and I'm not multiplying it by 2 because 16 times 2 is not 64. I'm actually multiplying it by that constant squared. See, 16 times 4 equals 64. Whatever this constant is, you square it and multiply it by the variance of the original. And that's how you get the variance of the new one. And then again, if I want the standard deviation, I just take the square root of the variance, which, since I'm multiplying, yeah, now the square root cancels those off. So you would get 2 times the standard deviation of d, which makes sense. 4 times 2 is 8. Okay? This works for any sort of constant scenario. So if I have a constant k times d, I just take that constant and I multiply it by the mean of d. For the variance of k times d, I just take that constant squared and I multiply it by the variance of d. And the standard deviation of kd would just equal k times the standard deviation of d. Oops, I gotta fix that. Standard deviation, not variance. Okay, so these, the green and the black, they're basically the exact same formulas. It's any sort of constant. Okay. Now, maybe you haven't noticed yet, but if you flip your sheet over to the back, so far we've done big idea 1, that's this blue stuff. Big idea 2 is the red stuff. Big idea 3A is the green stuff. Big idea 3B is the black stuff. Okay. So you might want to just pause this for a second and copy those down. Okay. And then once you got them done, start it back up again because we're almost done. We just need to finish up a few things. Okay, so D plus D, this is different now. It's called a dog and dog deal. You're going to take a dog and they're going to add on another random dog. It doesn't have to be the same size this time. 2D, it had to be the same size. This time you're adding on another random dog. So I could take a 10-ounce dog and I could mash it with a 10-ounce dog and get 20. I could take a 10-ounce dog first and mash it on with an 18-ounce and I would get 28. I could start with an 18 and mash on another 18 and get 36. Or I could start with an 18 and mash on a 10 and get 28 again. So if I typed those 4 numbers in a list and I found the mean, the standard deviation, and the variance, I would get 28. I would get 5.6569. And then if I square that, I would get 32. Okay, now here's the big thing I want you to notice, okay? 2D versus D plus D. They are not the same. Yeah, it looks like the averages are the same, but look at the standard deviations. They're not the same. The variances, they're not the same. Okay, so that is an important note to make, is that while in algebra 2D would equal D plus D, that does not apply for random variables. Okay, let me figure out a good place to write that. Okay, so 2D does not equal D plus D in the world of random variables. 2D would mean two identical things. D plus D is two different random things added up. So they might not be the same size. Same with like 3D. 3D would not equal D plus D plus D. It just doesn't work with random variables. Okay? So that's the only reason we did this D plus D, is so that you could see that they're not the same. All right, the last one is we're looking at adding on a constant. So what would happen if we took a random variable and we added on a constant? So this is like we're taking a hot dog and we're just adding on 2 ounces. So if I took a 10-ounce hot dog and I added on 2 ounces, I would have 12. And if I took an 18-ounce dog and I added on 2 ounces, I would get a 20. And if I type these in my calculator, I'm going to get 16, 4, and then square 4 to get the variance of 16. So look at the D column and the D plus 2 column. What are we doing with the mean? Well, we're taking the mean of 14 and we're adding on that constant of 2 and we get 16. Okay, so let's write that down. So when you want the mean of a random variable plus a constant, you can take that mean, the original mean, and you can just add on that constant. Okay? But look at the standard deviation. I'm not taking 4 and adding on a constant of 2. It stays 4. And standard deviation, or variance, again, stays the same. I'm not adding on that constant. So what you should write down is that the variance of D plus 2 doesn't change. It just stays the variance of D. And the standard deviation of D plus 2 doesn't change. It just stays the variance, or the standard deviation of D. These don't change. So anytime you are told to like add on a constant or subtract a constant, it changes the mean, but it does not change the standard deviation and the variance. Okay? So just to review the formulas, okay? If you are adding two random variables, you can add up the means. If you're adding two variables, you can add up the variances. But you cannot add up the standard deviations. You have to take the square root of the variance in order to get the standard deviation. If you're subtracting two random variables, you can subtract the means, but even if you're subtracting random variables, you still add the variances. Again, remember we added 16 plus 1 and got 17. And then to get the standard deviation, just take the square root of the variance. We're always, for the standard deviation, just taking the square root of the variance. When you are multiplying by any number, okay, any number, you can take the mean and multiply it by that number. For the, for the variance, you can take the old variance, but then you take that constant and you square it and multiply. So whatever this constant is that you're multiplying your random variable by, when you're doing the variance, you take that constant squared. The standard deviation, is the square root of the variance. So because you're multiplying, it actually does take off those squared. So you can just take the original standard deviation and multiply it by a constant. When you're adding or subtracting, you can add or subtract to the mean, but you do not change the variance or the standard deviation. And then this stuff over here, 2d is not the same thing as d plus d. Okay? So the blue was big idea 1, the red was big idea 2, green was big idea 3a, black is big idea 3b, and purple is big idea 4. Okay, so you should fill those out on the back of your sheet. These are the formulas we're going to be using when we do section 6.2 tomorrow. I just wanted you to see where they came from, and we'll actually use them tomorrow. All right, guys, have a good night. If you didn't finish the green worksheet, you're supposed to turn it in, but if for some reason you didn't finish it, then that would be considered your homework, because I am going to look those over. And then homework 1 and 2 are due tomorrow. Okay? Have a good night. Bye.